Yes, Assalamualaikum and very good afternoon. So I hope that you can hear me. Can you hear my voice before we start?
Yes, can hear your
All
voice.
right. Okay. Good. Okay. So we're going to start the class with the last lectures, which basically will cover on the testing part, right? So before we start the class, just have some announcements. Let's go here. Okay, so this is regarding the submissions of your project. So I actually have extended. So I have agreed to extend your group submissions. So the last day for your submissions will be on 8th of January. So instead of 6, it will be on the 8th of January on Sunday. And the times is I put here is 11:59 p.m. So make sure that you submit by 8th of January. So I will extend around 2 days. So basically, now this is only for TME 2413, TMN 2223, and also TMS. So basically, all the course code under me, lah, right? Not for the other courses. So the other courses or the other classes, they will still need to submit by 6, yeah, if I'm not mistaken. One of the reasons that I wanted to extend because we finished the class a little bit late, yeah, especially on to cover the testing, the software testing, which is the last lecture here. So I think it's much better if I extend 1 or 2 days. It will be enough for you to do your submissions. But the submission link will be open in eLib. Yeah, so if you wanted to submit early, yeah, also can as well. So I will just open the link. It will be open on the Friday of 5th January, right? If you wanted to submit early, lah, right? So basically, again, just to remind everyone, the submissions due date for the project will be on 8th of January 2023, only for these three course content. Okay, so all that is clear. Okay. Okay, now the last lecture will basically cover on what we call as the object-oriented system testing. So before we start, maybe I can share some of these videos in YouTube, basically on what software testing is all about, so that we get some basic ideas, and we will see some of the testing strategies that will be covered in this lecture. Okay, just wait for a while.
Nhiều sự nhiên.
Rồi. Tổng số điện rồi.
Share 那东西，share screen 吧，应该是还没有 share 那 browser。
Is the video lagging? Can you see the video or not? It's lagging a bit. All right. Okay. Okay, never mind. What I will do is I will just share the link here. Yeah, if you need to watch the video again, you can just go and watch on your phone. Basically, the video is just about the introductions on the software testing, and then what are the importance of having software testings as part of our software development process. Okay, so I will just continue with the lecture. So if you wanted to watch the videos again, you can just put the link that I provide in the chat sections there, and you can just watch it later. Okay, now what we will cover in this lecture. Okay, so basically when we are going to look at what about is software testing is all about, mainly on the quality assurance, and then what are the testing strategies that we have basically in the software testing. There are few testing strategies, but the one that we're going to look here is mostly what we call as the manual testing. So testings nowadays can also be automated. So you can do automated testings instead of manual testings. But it does not really necessarily means that manual testings is not important. So we still, although we have an automated testings, we still need to have a manual testings as well. So there are few testings that we can conduct automated, and then there are some testings that still we need to do it manually. Yeah. So this is what we're going to do today. And then we're going to look at these object-oriented testing. So there are a few techniques when it comes to object-oriented testing methods. And the last one is basically on how to develop test cases and also test plans. So at least by now, you already have an ideas how to develop a test case. This is basically what you do in your projects. So you develop a test case and then you come up with what called as the test plan. So basically you know how the test, what are the test cases, how do we get the test case, and how do we conduct the test plans. Yeah, basically we come up with recommendations. Okay, now when it comes to software testing, so the first questions that we wanted to ask is why do we need to conduct software testing? So we know that software testing is basically one of the last stages in any software development life cycles. So these stages or these phases must be included whenever that we wanted to develop a system. Okay, so one of the reasons is that we wanted to make sure that the software that we build or the software applications that we have actually meets the requirements and functions. That is the most important one. Number two is we wanted to make sure whether there's any bugs, issues, or errors that we can actually identify, and also we can actually correct in the system. So that is why the testing part is very important because we wanted to find as many errors or as many bugs as possible in our system. Yes,
有
can
吗？
you
哪里有？没有啦。
这个都有吗？
记得我一天没有 charge 2次了，已经够好了。
你们是胆子
can you mute your mic? Yeah. Right. Thank you. Okay. So and also the third one is to make sure that the software that we have or that we build is mostly secure and reliable. So based on the video just now, there are some issues or there are some problems when you have errors or bugs in your programs that that can include or that can cost lives and also in terms of money as well. So you can look some of the examples of the issues and also cases that actually happened when there's an error in the software, right? So mostly in the critical software should have or should be what we call it as the error-free, especially those software, for example, if it's involved like in pay plans or they're involved in medical health, for example. So those type of software should always be reliable, and so should always be secure. Okay, and of course the last one, why do we need to conduct software testings? Is basically we wanted to make sure that all of the requirements that we have actually meets what the user needs. Okay, so if you look at the first point here, in order for us to develop and deliver robust systems, number one, we must make sure that each of the components will behave correctly. So we need to test each of the components, so each of the modules, and then after that, we need to test the collective behaviors, either for each of the components or the interactions of the modules among each others. And also, we must make sure that it should be correct, and in terms of behaviors as well, there should be no errors. So that is basically why we need to conduct software testings. Okay. So testings includes the testings of components or individuals objects. So the components here can be referred as the modules, and also not only modules, but also we need to test the individuals objects as well. Mainly if we test on individual objects or individual components, we must make sure, number one, that the behaviors is correct, and also the interactions between each of the components and also each of the objects is also correct, right? Now, this is some of the examples. This link here might not be working anymore, but if you can just Google up, you can just Google 10 biggest IT mishaps in history, or 10 any problems with IT. Basically, some of the examples that is shown in the video just now, you have the aeroplanes, right? The airplane systems. You have some problems in the medical health. Yeah, we have this thermal scanner just now. So those are some of the biggest IT problems. Yeah, there are some problems with the software that actually can cost lives and also some money as well. Okay. If you have heard about Y2K, right? Y2K problems. So this is actually one of the biggest problems before the 2000, known as the Y2K problems or Y2K bugs, right? Because previously, most of the systems was developed in around 1960s, right? And also around 1990s. Okay? So most of the systems, actually, they just use the last two digits here when it comes to represents a particular date. Yeah, for example, 68 or 95. So represents 1968 and also 1995. But the problems happen when it comes to the year of 1999, where the systems need to update the calendars to the year of 2000. Now, most of the calendar date systems or the system that used previously, they just use the previous two dates in here to represent the year. So when the year of 99 is about to end, and then moving to 2000, so this will cause a problems, because later on, if let's say the computers change this into just 00, then the systems might think that this is actually the year of 1900. So this actually will cause a problems, especially in the banking systems, because we don't want the systems to recalculate any, for example, any tax or any interest, yeah, that happens from the 1900s. So this is one of the biggest problems in the year 2000s. So some of the systems are actually, mostly the banking systems, they have problems with this Y2K. And even, for example, in the year 2010, we have this Y2K 10. They call it Y2K 10 problems as well. but it's not that similar with Y2K. There are just some problems with on how to represent some of these decimals and also values in the 2000 as well. In fact, in this in last year as well, they also have this year 2022 problems. We can take a look at it. What are some of the problems that actually have mostly on the numbering systems, on how they actually represent the numbers in the systems. Okay, so those are some of the problems that actually happens, and also we need to think of when we develop systems. So this is why some of these problems actually need to be find out earlier so that we can do some corrections to the systems. So the previous one that you see just now is on direct radiation therapy machines. It's actually malfunctions and it actually cause some lack with the patients as well. Okay, and also not only in terms of life, like I said before, it also can cause some financial losses as well. Okay, so I mean, if these things actually happens in many of the systems, it actually happens. For example, if you, I think Shopee previously they have these problems where you can actually buy some of the products, but you just need to. Sometimes you don't need to pay, or sometimes it's actually just free. You don't need to pay on this, if I'm not mistaken, or Shopee. So those are some of the problems that can actually cause what we call as the financial losses, right? So it will cause some of the problems to the business and also services as well. Okay. Now, in a Malaysian context, there's a lot of what we call this IT disasters. Maybe one of the most common one, or the most recent one, probably we can say in terms of the data breach, right? So we have this MCMC, Malaysian Communications and Multimedia Commissions, right? So where the data of the customers actually is the data is actually leaking, and other people can just actually access this information. So this is also some of the what we call it as the IT disasters as well. So we don't want this to happen. So it is better that we provide or we build systems. Number one, not only have a freeze, but number two is secured as well. Okay. Number two, what happened for smaller software failures? So even for smaller software failures as well, it will actually still impact the systems. So we actually have see these problems a number of times whenever we use a system. For example, if we use the registration systems, cost registration systems, it may be crash, right? Some of the applications will show an errors as well. So this is what we call as the impact here for smaller software failures. So it still have some impacts for what we call as the minor inconvenience to the customers or to the users. So it is big. It's a big systems or is a small systems. Still, testings is still very important that we need to do our development as part of our development. Okay. Now we look at the quality assurance test. So what is a quality assurance test? So quality assurance test is basically a testing process and also includes the debugging process as well. So when it comes to testings, part of testing process is basically a debugging process, right? So debugging, you know that when we debug the programs, is basically we wanted to find out what is wrong with our code, for example, and we wanted to eliminate the errors or the bug. Okay. So the purpose of quality assurance again is similar like the previous one. Like I said before, when we want to do testing, we wanted to make sure that the programs or the software that have actually meets the requirements and also functions as expected. Okay, so it can involve, for example, like debugging process where we try to find bugs, and also we try to find errors and probably any other issues as well that we can find in our software in order for us to make sure that the software that we have actually meets the requirements, yeah, and also functions as expected as well. Okay, so it's actually parts of the software development process. Yeah, it's part of the testings. So we just wanted to make sure that the software that we have is in a high quality and can be used by the users and meets the needs of the users as well. Okay, so debugging process is very important because some of the bugs here sometimes it is hidden. Yeah, so sometimes the bugs might be you can just look at it and then you can just find what are the problems with your coding, for example. Maybe the most obvious one is on the syntax error, for example. So those are the things that we can see, right? But some of the bugs, they might be hidden. Yeah, for example, we talk about logic errors. So until we do some testings, then we can find out what are the problems with the systems. Okay, so there are no magic tricks to debugging, and there are many types of errors that we can find in our program. So the most obvious one, or the most obvious problems that we always have is what we call as the syntax error. This is happen when we do some incorrect punctuations, right? Some of the punctuations that we omitted, for example, there are brackets that we did not include, for example, semicolon, etc. So these are all what we call as the syntax error. Okay. The second one is what we call as the runtime error. So the runtime error, for example, if let's say we divide a value by 0 and then we will give you an undefined value, for example, so infinity values, for example. So this is what we call as the runtime errors. And then the third one is what we call as the logic errors. So logic errors, basically our code is correct. Yeah, there's no errors with the code. There's no syntax error, runtime errors, and etc. But once we run the coding, right? But it will produce what we call as the incorrect result. So this is what we call as the logic errors. Okay. Part of the testing process here is what we call as the debugging. Now, quality assurance testings, we can divide it into two. Number one is what we call as the error-based testing, and the other one is what we call as the scenario-based testing. Okay, for the first one, error-based testings, this is also known as the boundary testings as well. So we need to test different types of inputs based on the boundary. So we can set a particular boundaries, and then we try to test what are the values if you put the value less, yeah, than the valid values, or if you put maximum values than the valid values again, right? So this is known as the boundary testings or error-based testing. For example, here, let's say we need to test a valid value from 1 to 99. So the systems only accepts value 1 to 99. So the invalid value in this case will be 0 and also 100. So any values that less than 0 or any values that more than 99 will be considered as invalid. So we can do this as the error-based testing. The next one is what we call as the scenario-based testing. Scenario-based testing is basically we try to look at how do the users use the system. So we can create an environment where we can actually see how the users operate or use our systems, for example. Now, most of these is for example, if we talk about usability testing, right? So it is also one of the examples of what we call as a scenario-based testing. Yeah? So we're just going to just create an environment, and then we try to look at how the users actually use the systems and how they apply any functions or any functionality in our systems. Right? Okay. So when we talk about testing strategies, basically we have these four. The first one is what we call as the black box testing. The second one is white box testings. The third one is top down. And the fourth one is what we call as the bottom up testing. Okay. Now, between black box and white box, there's also what we call as the gray box testing. Gray box testing. Okay. So, but most of the most common one is black box and white box. But sometimes they just combine these two. They call it as the gray box testing. Okay. So we're going to look at each of these testing strategies. Yeah, what is this black box, white box, top down, and also bottom up testing. Okay, now in black box testings, why is it called black box? Is basically going to treat the logic. Yeah, so what actually happens inside of this box will be unknown to the testers. So the tester basically don't know how the systems will operate. Yeah, so how the systems will operate and what are the logic inside of the systems. But what they're going to do with the systems is that they're going to provide what we call as the input, and then they're going to look at what are the outputs. So basically, black box testings is where we test the applications without having any knowledge about the systems, and also without having any knowledge of the internal structures or the coding inside of the systems. Okay, but we use this black box testings is basically we try to identify bugs or issues that we can identify in the systems. Right, so that is what it is called as a black box testing. Okay, so the black box testing works very nicely in the testing environment in OO. So there are many types of black box testings actually. For example, if we talk about unit testing, yeah, all of this what called as functionality testings, unit testings. We have integration testing. So all of these can be considered as the black box testing. Okay. All right. So the black box testings is the one that we usually use in what we call as this in the OO environment. So most of our testing strategies will include these black box testings. And once we have fully tested all of the classes and objects, okay, and then and if it's already successfully tested without having any errors, so we can just put them into libraries so that later on we can just reuse the classes, or we can just reuse the objects as well. Okay. So the next one is what we call as the white box testing. Okay. So the white box testing here. Now in the black box testings, we know how the internal structures of the system. So basically, we just wanted to test. We were given this input, particular input, and then we're just going to observe the output. But in white box testing, okay, this is where the testers itself, right, the one who tests the systems actually knows what is actually happening inside of the systems. Okay, for example, if let's say the testers put the value of A equals to 2, and that actually knows, so if let's say A is equals to 2, then it should print B, for example, and then B is the output that we should get based on the input that we put before, right? So in this case, in a white box testing, the testers basically knows what is actually happening inside of this box here, inside of your coding, also inside of your system, right? So now this is also called what we call as the path testings as well. And there are two types of path testings. Can include this what we call as the statement coverage and also branch coverage. So the white box testing here, it can actually include these coverage testings that we have, for example, the statement coverage, and also a branch coverage testings. Yeah, it can include other testing strategies, as in, for example, like code reviews or dynamic or static analysis. But the most common one, when we talk about white box testings, we have this what we call this part testing, segments coverage, and also branch coverage. Okay. Okay. Now, what is meant by statement coverage and also branch coverage testings? Okay. So when we say statement coverage, so this is basically we wanted to test every statements in the programs, and it must be executed at least once. So when we write our programs, right, there's a few statements that we have from the first statements up until the last statements that we have. So each of the statements in our coding will be executed at least once. So this is known what we call is the statement coverage. Okay. Now in branch testing, we're going to look at the branch alternative that must be executed at least once, during some testings. So the branch coverage here, or the branch testing here, will basically look at the conditions that we have in our system. Okay, but for statement coverage, we must execute all of the statements that we have in our program. For example, if you look at this chart here, right? What are the examples of this coverage examples? Now in here, for statements coverage, we have around 7 statements and 1 case. Okay, so X more than K is considered as 1 case. So the 7 statements here comes from each of these statements here. So we have 1, 2, 3, 4, 5, 6, 7. So in our coding, we're going to have each of these statements. So we need to execute all of these statements here for the statement coverage. Okay, but for branch testing, we're just going to look at the branches, right? For example, we're going to look at these conditions here: X more than K and race is more than 0, for examples. Okay, so each of these we're going to have at least 2 cases, right? Number 1 is either X is more than K. If it's yes, then what will happen? If it's no, then what will happen? So if X is less than K, then what will happen here? So this is known as the branch testing. So we're just going to look at the branches or the conditions that we have in our systems, okay, or in our coding. Now the next one is what we call as the path testing. Okay, so the path testing is basically when we wanted to when we built our systems, there are a few ways on how we can actually execute the systems, for example. Now, each of these, what we call as the ways to complete the task, there can be many parts. Yeah, for example, if let's say this is our start, right? Let's say this is the algorithms of our systems, and then this is the end of our systems. Now, from start to end of the program, right? For example, you can just go to conditions in here, for example, or you can just go to conditions in here. Okay, and then there's another conditions in here, right? For example, you can do some of these statements, and then we can just complete the systems, or you can just go directly in here, okay? Or you can just go directly in here. Okay, so in this case, there are a few paths on how you can actually complete the systems. Either we go here, 1, here, 2, or here, let's say 3, for examples, or 4. Yeah, so we have 4 paths in here for our path testing. Okay, so this is basically on the statement coverage, branch coverage, and also path testing. Okay. So before we go with the top-down testing and also bottom-up testing, so give us some examples on this statement and also branch testing. Okay. Now let's say So let's say we have source code. Yeah, for examples, we have in our coding. So let's say we have a method, say called print. Let's say two values, integer a and integer b. Okay, this is look at statement coverage. So if you look at this statement coverage first, statement coverage. Okay. Now, usually for software engineering students, they actually will learn this more in the software testing course. Yeah, there's one course that you need to take, I think, during the final year, which relates with software testing. And then at the end of the course, I think you need to take some, you can actually sit for an exam from MSTB, Malaysian Software Testing Board. MSTB, you can sit for some exams, and then if you pass the exams, you can get some certifications for you to be what we call as a software testers. Yeah, I'm not sure if they still have these programs, but previously they still have this MSTB what lah, yeah, Malaysian Software Testing Board. Okay, but for statement coverage, so let's say in this case we have functions to calculate two values. Yeah? So this is actually a function. Okay? And then let's say we have integer result. Okay. So integer results, for example, a plus b. Okay. And then we have a conditions, for example, let's say if results is more than 0, for example, okay, then we print, let's say, I'll repeat, followed by result. Else, then we print, meaning that the value is less than 0. So we print, let's say, negative. So, okay, so let's say this is our source code. Okay. Now in statement coverage, so it will actually execute all of these statements here. Okay, all of these lines here. 6 up until the last one, up until this bracket in here. Okay. This is what we call as the statement coverage. Okay, so it will actually execute. Yeah? It will actually execute each of the statements in our coding. Yeah? For example, in this case, if let's say we have the value of a equals to 3, for example, and then b is equals to 9. Okay. Now in this case, the statements that will be executed in here will be based, in order for us to calculate what we call as the statement coverage. Yeah? How many statements does it actually cover? So statement coverage is calculated based on number of executed statements divided by total number of statements. Okay. Now this one here is just for your information. just for you to just actually knows what is statements coverage, how does it actually works, right? But you don't really need to know into details what is statement coverage. Just you should know what is statement coverage is all about, and how do we actually use it in, let's say, in software testing, for example. Okay? I just wanted to share some of the examples for the statement coverage. Now, in this case, we have around 7 statements in here, right? So the number of statements that we have is around 7. Okay? So in this case, if let's say the value is A and the value of B is 9, for example, so the one that will be executed in here, we will execute these statements, okay? And then we will execute these statements. So A plus B, A plus B is 3 plus 9 is 12. And then here, if result is more than 0, and then we print, which is 12, which is more than 0, and then we print result here. And also we are not going to execute these statements because this is already true, but we need to execute the last statements in here. So we have around 1, 2, 3, 4, 5. Okay, so we execute around 5 statements in here, and then so in this case we get around 5 divided by 7. Okay, so it's around 71, 0.71. Okay, and we can multiply by 100, so we get around 71% coverage. Okay, now this is what we call as the statement coverage. So this is how we execute the statements for each of the lines that we have in our coding. Now the next one is what we call as the branch. Okay, so the branch testing or the branch coverage here is basically we're going to look at the examples that was given here at the branch alternative. We're going to look at the conditions that we have in our system, in our coding. Okay, for example, okay, so for example, let's say a branch coverage. Okay, so to calculate the branch coverage, is basically we're going to look at the similar as well, the number of repeated branches divided by total number of branches that we have. Okay, the number of branches. Okay, let's say, for example, if let's say we have functions, so let's say we have demo here, let's say integer a, now if a is more than 5, for example, so a equals to a multiplied by 2, and then we print value of a. Okay, now in this case, we have what we call as the conditional branch here. Okay? So we have this functions of integer a, where if the value is more than 5, right? So if the value is more than 5, then we print this value. Or if it's not, then we're just going to print this value in here. Okay? So basically they are what we call as the tree three total number of branches that we have here. Okay, never mind. So we just go with branch testing again. So branch testing, branch coverage, branch coverage. So we have some demo. So A, and then we have if the value of A is, let's say, A is more than 5. And then A we multiply by this string. And then we print the value of A. For branch coverage, we have what we call as the conditions in here. Okay, so in this case, we have if A is more than 5, then we print the value of A, else then we're just going to print the value of A, just print the value of A. Okay, so we can create what we call as a test case for branch coverage. So test case number 1, for example, if let's say going to test the value of say here test so test here, and then we have value of A, okay, and then we're going to the output. Okay. So let's say this is test case number 1. If let's say the value is 2, right? So the value is 2, and then if it's A more than 5, so 2 is less than 5, right? So the output is 2. If let's say we go to the next value, let's say test case number 2, going to test the value of A that's set is 6. So 6 is more than 5, yes. So 6 times 3, which is the value will be 18. Okay. Now, in order for us to calculate what we call as the branch coverage, we need to look at the numbers of execute branch, number of executed branch executed divided by total number of branch. Okay. Now in this case, the total number of the branch for the first test case here. Okay. So in this case, we have the first one for the first test case. So we actually execute 1, okay, and then the number of the branch that we have is 3. Okay. So 1 divided by 3, we will get around 0.33, and then multiply by 100, so we get around 33% of the branch coverage. if we look at this, that is an example for a branch testing. So we execute at least one conditions for the branch testings, divided by the total number of the branch that we have is around, we have around 3, right? So we actually have 3 because we have this conditional branch. If A is more than 5, then we get the value. But if it's no, if the value is less, then we're just going to quit it. So this is also known as the unconditional branching as well. So these are examples of coverage testings and also of branch testings. Okay? But of course, it will not be asked in your exams. Just that you should know, or you should know how to differentiate between statement testing and statement coverage testing, and also a branch coverage testing. Okay, now we move on with the next one is what we call as the top-down and also bottom-up testing. Okay. Now the first one is what we call as the top-down testing. So sometimes we call it as the top-down integration testing. Yeah, because what we need to do in top-down is basically we need to look at the interactions. Okay. So that's why it is called top-down integrations testing. Okay. So the main logics and also the object interactions in top-down testings is more, we need to test more of these interactions of the main and also objects than the individual objects methods. So in this case, in order for us to look at what are the behaviors of the lower level modules. So we have a few levels for our modules, and then we need to look at how the interactions of each of these modules from the top up until the bottoms of the modules. So if we look at here, this is what we call as the stubs, right? So level 2 here, you have some stubs, and then we have level 3 stubs in here. Okay, so stubs. So the stubs here basically are just modules. Okay, so it just acts like a temporary replacement for the modules, but it will give the same output for the products. So this is just for the purpose of testings. So just we're going to replace these modules known as the stubs in order for us to look on how the interactions from each of the levels that we have in our modules with another modules as well. Okay. Now this is what we call as the top-down testing. Okay. So another examples, maybe you can give you, let's say we have a top-down testing. Let's say we have this module. So this is your first module. This is the first module, and then this is our second module, and then this is our third modules. Okay. So under 2, you have what we call as the stubs. So let's say this is stub 1, and then this is stub 2. So similar with this one as well. So we have stub 1, and this is stub 2. Okay. Now in this case in here, we have these few levels from modules, let's say modules 1, modules 2, and module 3. So we need to actually integrate all of these modules. But when we look at below of the modules, there are some of the modules that are still what we call as the under development, and also we cannot integrate the particular types. Yeah, so maybe they are still under development. Some of this functionality, for example, in level 2 here. So that's why we're going to use instead of the functionality or the modules itself, we're going to use the stubs, yeah, to actually test the modules. Okay, so in this case, if we use a top-down approach, in this case, we can actually test, in terms of the integrations, we can test modules number 1 and modules number 2 first, okay, and then going to test modules number 1 and modules number 3, right? Okay, and then after that going to test modules number 2 followed by step 1, okay, and then modules number 2, step 2, and then modules 3, step, so this is 3, step 3, and then module 3, step 4, for example. Okay, so the testing approach for the top-down integration testing. So first, we're going to integrate the first 3 modules, modules number 1, 2, and 3, and then we're going to test the integrations between modules number 2 with the steps in here, and then we're going to test the integrations between modules number 3 and also the step 3 and 4. Okay, this is known as the top-down integration testing. Okay, now for bottom-up testing, we start from the bottom, as the names mentioned here. But what we're going to test at the bottom is basically we're going to test each of the components at the lowest hierarchy in our system or in our programs, and then we're going to test it individually, and then the components that actually need these components are being tested as well. And for example, there was given here, so we can start with methods. So we start with method first, and then we combine them to see the interactions and also messages. So let's say we test method 1 and 2. Okay, let's say test method 1 and 2 is okay, correct. And then we're going to test method 3 and 4. And then we're going to look at the interactions between each of these methods, if they are need some interactions with each other. Okay? So this is also known as what we call as the bottom-up testing. Okay? So similar examples that we can see in here. Let's say we have modules. Okay, so let's say this is module 1, and then this is module 2. This is module 3. And then in the modules 2, we have another sub-modules. Let's say we have 4. Here we have 5. Okay. And here we have 6 and 7. Okay, so using the bottom-up approach, so the integrations or the order of integrations that we can do, for example, we can test the submodules of 4 with 2, and then we have to test 5 with 2, for example, okay, and then we test 6 with 3, and then 7, 3, and then 2, 1, and then 3, 1. Okay, so basically the lowest models here, right? The lowest models here, 4, 5, 6, and 7. So this is the one that we need to test first. Okay, now if you look at modules 2, right? So you need to test as well modules number 4 and also modules number 5. Okay, and if let's say there are problems with interactions between 4 and 5, then mostly 2 will not work, because 2 actually needs 4 and also 5 as well in order for it to work. Okay, so this is how we do what we call as the bottom-up testing. Okay, another example that was given is based on this in the slide. We can refer to this. Okay, Now, in the bottom-up testings, basically, the modules that we have is what we assume it is fully developed and as a standalone. So meaning that you actually need to test each of the functionality first in your programs. So we assume this as a standalone process. So we test the functionality, for example, the methods first, and then we move to the next one. Okay? And these modules are tested individually. So we test one by one, and then we combine for integration testing. So we try to look at, for examples, with another class, if there's any method that actually needs some information, or we need to integrate some of the informations based on the modules or the functionalities that we have. Okay, so bottom-up testing is more what we call as appropriate for object-oriented systems. So in this case, we have a few classes, right? We have a few classes with a few objects, and we need to test the functionality first, the methods first, and then the interactions of the method with another class, for examples. And then after that, we go to the next level of it. We test the class, and also we test the interactions with another class. Yeah. Okay. Now, what are the impacts of object-oriented on software testing? So it does says in here, when we do some inheritance concepts, it can actually make the systems much more difficult. Yeah, so there are some guidelines when it comes to inheritance concepts. How do we test systems that use these inheritance concepts in object-oriented? Okay. The examples that was given here, for examples, when you invoke a method, it may belong to many classes, and when the code accesses it, it may get an unexpected value. So you have a method, so one method, but it actually belongs to many classes. Yeah, let's say we talk about the concept of polymorphism. Okay, so where you have the same methods, the same name of a method, but can actually belongs to many classes. Okay. Now in for environments, so if let's say we have a non-object oriented, so X is complete payroll. So we know that we're just going to do some computations on the payroll for this X object. But in OO environment, let's say you have a manager that inherits from the class of employee. So you have employee, and then you have manager. Okay. Now in this case, each of these class, they have what we call as the complete role. Complete role here. So the manager actually inherits the same complete roles, but the implementations for each of the employee might be different. Yeah, for managers, I think we have looked at these examples before. The calculations of payroll for manager is different from the others. Okay, so you need to think about the behavior of a single functions, and it will be much problems if we have what we call as the multiple inheritance. If let's say this class inherits from another class with the same function, for example, then it will cause some problems. Okay. This is another examples of impacts of inheritance in testings. So you have a superclass and also a child class in here. So in this case, you have this move forward from the superclass, and also you have the same functionality of move forward from the child class. Okay, the base class here, which is a superclass, you have these two methods, turn left and also move forward. Now the derived class actually redefines this move forward from the superclass or from this base class. And we need to think, if let's say this is the same methods, if this is the same method, the same name of a method, do we actually need to test again, this method? Yeah, since this is the same methods that we actually inherit from the base class. So the derived move forward need to be tested since it is a new code. So let's say here you actually redefine, right? You redefine the methods of move forwards from the superclass. So meaning that you need to test this method, and also again you need to test this method as well. So does derived turn left need to be tested? Okay. So if it use move forward and move forward has been changed, then it need to be tested even though derived turn left has not changed. So either that's, you can say in this case, the turn left actually, the move forwards from the child class actually needs to use these methods of a turn left. And it has actually been changed, yeah, in this child class, then it should be tested as well. Yeah. So the move forward just now, you have the two methods, the same methods, but actually there are two different methods. Although the name is the same, but they have different protocols and also implementations. So in inheritance, although the name of the function is the same that inherits from the superclass or the base class, but still, if you redefine any process or any activity inside of these methods, then you need to do a separate testing, a different set of test requirements. Okay. Okay. Now the next one is what we call as the test case. Now the test case, like I said before, you already have an idea what a test case, how it looks like. So this is just some of the reviews, how the test case look like and how you come up with a test plan. Okay. So in order for us to test the systems, we need to do some of what we call as the test input. We need to have some test input, and then we need to describe how the output will look like, and then we will do some comparisons with the expected output that we wanted to get from the system. Okay. Okay. Now, in order for us to come up with the test cases, you can actually just refer to your use cases. Okay, so the use case can actually help you to define what are the suitable test case that you can actually develop. Like for example, in the use case, we have a register cost, for example. Okay, so in your test plan, or you can actually develop these test cases of register costs here. For example, like login. Right, so those are the things, or those are the functionalities that we can actually identify, and we can build what we call a test case, or test cases. So the test case is basically we need to find what we call as the errors that we have in our program. Okay, so a good test case, if we can detect it earlier, and then we can do some corrections. Okay, so basically, a test case is what we call is what if questions. So if let's say you put some values, then what if you put some values, then what are the possible values that we can get? So for example, in this in here, if let's say you receive some input, and then it should produce certain output. This is basically the ideas of test cases. Okay. This is just some of the guidelines. How are you going to develop a test case? You need to look at the features, right? The functionalities or services that you are trying to look at either in your use case. Yeah, you can just refer to use case and just use the same name, yeah, from the use case that you have. Okay, and then you need to specify what are the input that you're going to get, and then what are the output, yeah, expect to happen in your plan. Okay, and then test the normal use of the objects methods. Yeah, if let's say if you put a normal values in a particular test case, then what will happen? And then you test an abnormal values from the methods or the features that you're going to have, and then you try to look at what will be the outputs. So we can test using a boundary conditions. That if we use some of these boundary conditions just now, for example, like values from 0 to 100, for example, and what will happen. And then we'll look at the interactions as well, the messages between the functionalities of between the objects, and then we do some documentations. This is on the test plan, and then what if questions, yeah, and you just going to do all of this process until you have covered most of the functionalities in your system. Okay. Now, a test case format usually looks like this. Yeah? So if you get some inputs, then it should produce some output. Okay, so this is an example for bank ATM systems. So if a bank client insert his or her card, then system will respond by posting the password. Now, if the password is incorrect, the systems will display the bad password message and eject the card and ask the client to take the card. Okay, so after the transaction is completed, the system should show the main screen and etc. up until it completes its task. And these are the examples on how you can actually create a user account test case. Yeah. So in this example, you need to generate at least 10 test case for this particular use case of create user account. Okay. So based on the use case, so the UI is shown in this diagram. Okay. So you need to enter all of the information here, username, password, and etc. Then you can register to the system, so you can create a user account. Okay. So these are some of the possible test cases that you can do based on create user accounts. For example, if the user submit create user forms, if let's say the username is blank and the other fields is valid, so they did not put the usernames, then it should display some errors in here. Similar with the others as well. So all of the information here must be keyed in correctly. Then you can create some user accounts. Okay, so these are some of the test cases that you look at. Okay. Okay. And then for this one, for the error message, is actually how you handle the error message. Here, for example, you go to the user ID field without entering the data field. And so instead of for example, this is on how you actually improve the system, the user interface of the system. For example, let's say the user go to the user ID fields, but did not put any values in the user ID fields. So we can provide the systems. You can actually create a message to the user to remind them to actually enter the user ID. Yeah, so and etc. You can just take a look at this. Similar as well with the other examples. So this is on how you can actually handle what we call as the informations or errors that you have in the systems, and how you can actually improve it on your user interface. Okay, now test plans is a documentation. It's basically a documentation that actually mentions about the test objective. Yeah, why you need to conduct tests, how do you conduct tests, and the schedules, yeah, the timings on how you actually do, how many months, for example, for how many weeks you actually do the testing. So all of these informations should be put in one documentation. We call it as the test plan. Okay, so these are some of the steps in order to create test plans. Objective. So you need to define why you need to do the testings, yeah, and how you can actually do the testing. So meaning that in here, you need to identify what are the suitable type of testings that we can do. So if let's say we do black box testing or white box testing, so if we do both, then we also should explain. You know, so why do we need to choose, for example, a certain testing strategies for this particular system? Okay, and then we develop the test data. So in this case, basically we just build a tables, and then we just put some input values, yeah, and also the output values. Now this is mainly on manual testing. And then we do what we call as the test analysis. Then we try to look at the outputs, and then we try to document the test results. Okay. Okay, so you can assign other people to do the testings if you have a clear and a good test plans. Yeah, so this is, for example, if you are ready for what we call as the beta testing. right? So I think I've mentioned about this before, where you try to ask for the users to actually test the systems, so you can actually ask them to do the testing. Okay? Um, and also you can just track what are the functionality they have tests, yeah, how they do the testings. Yeah? So all of this is must be put in the test plan. Okay? So who should do the testings? So this is in terms of the talk about alpha testings, in-house testers. Yeah, it can involve with the designer itself, the quality assurance groups of the software for alpha testings. It can include this in-house testers, programmers, etc. Beta testings is done by actual selected users who will use the system. Okay. In terms of the format, there are different types of formattings for the test plan. You can just refer to any of the standard testing plan. But it should actually contain, for example, like the schedules, yeah, when the process of we do this testing, when you start the testing and then when you end the testing process, what are the resources that we will need, yeah, what are the tools involved, and what are the improvements needed. Okay, for example, if you say it involves of this automation testing, okay, so the automation testing, um, it actually use, for example, you can use like a Selenium. So Selenium is usually we use to test an automated web page. Okay, so this is an example of the software systems that we use to actually automate the testing process. So you can just put in the testing plan as well. Okay, and what type of testing that we do? The bottom up, top down, black box, white box, yeah, etc. Box and etc. Okay, configuration controls. This is basically the versions of the test plans. So sometimes we need to come up with a configuration controls. For example, maybe 1.0. This is the first version of the test plans. And then if let's say we have to do some modifications of this test plans, and then we can come up with a version of 2.0, for example. Yeah, so this is our what we call as the configurations controls that actually mentions how the model has been changed, who will do some of these changes, yeah, and also explanations why the changes actually have been made, yeah, in the system. So all of this will be put in what we call a read test plans, and then we need to keep the test plan up to date, yeah. So there are a few versions that we need to come out, and then once we reach the milestones, yeah, and then we can just complete the routine updates of the test plans. Okay. So as a summary, we can say that testing is basically a balance of art, science, and luck. Like I said before, maybe there are some errors or bugs that we can actually did not find, yeah, because they are hidden. So this testing process needs to be done diligently and also thoroughly in order for you to get good systems, yeah, of the pre-errors system. Okay, so the quality assurance will actually look what are the project problems in the proposed design. So once we identify an error, maybe we're going to look at the design as well. So what are some of the changes that we can actually do based on the design? Okay, we must develop a test plan in order for us to document everything. So we need to come up with a test plans. Okay, and it's actually of course as what called as the roadmap activity for the testing activity, yeah, on how we can actually do the testing and how we try to achieve that testing. Okay, now before we end, we're just going to discuss some of these tutorials, the last tutorials for this particular lecture. Right, so we have tutorial 10. I'm just going to share this one. Okay, so this is the last tutorials on software testing. So if we're going to look at the first one, yeah, so what is debugging? Debugging is a process to find and also correct and also eliminate the errors. So there are three types of error that we can see in the previous slide. So we have logic error, runtime error, and syntax error. Okay, now we have these examples here. The first one is void my functions and then VC out executed. Now what are the type of errors that we have in here? This is obviously this is a syntax error,
Error.
right? Syntax error. So we can actually look at this value here and also this one here, right? This is a syntax error. The second one, integer x is equals to 2, y equals to 0, y is less than 5, and y plus plus. Then see out the value of x. X is 2 times x plus 3. If y is 1 times 2 is equals to 0, and x is 3 times x plus 2. Okay. Now if we execute this, then we get the value of x. So the first one, the value is we see out x, so x is 2. And then we multiply 2 or 7, right? So this should here x should be 7. And if y is 0, modulus 2 equals to 0, is correct. So 7, 1, 23. So x is 23. Okay. And then y is 1, right? Now if we going on here, yeah. So if we continue in here, we will get that here, right? If we increase the value of y and y is 0, if we increase to 1, so 1 modulus 2 equals to 0, we will actually still execute this value. Okay, so in this case, this is what we call as the runtime error. And no, this is a logic error too. This is logic error. This is logic error. Okay, and the last one here, a equals to 0. So anything divided by 0, we get this undefined value. So this is what we call the runtime error. Okay. Okay, which two strategies are more suitable for over testing? So in this case, actually all of these are suitable for object-oriented testings. We discussed about black box testing approach as well, even in top-down approach. But if let's say which one is more suitable, so in this case we can say that bottom-up approach and also black box approach is more suitable for object-oriented system testing. The last one is on the test case. So let's say one of the use case for, let's say, hotel reservations and management systems is potential customer checks available of rooms. So these are the scenarios. So the users enters the check-in date. So the users enters check-out date. And then the systems will display available room and the price. And the user can click the rooms for other facilities. Based on the use case above, we need to develop a positive and negative test cases with attention, input, and expected outputs according to the template provided. So we can do something like this. We can do a positive test case and also a negative test case. So, for example, the first one is the user need to enter the check-in date. So the user should be able to enter or can check the check-in date. Okay? So it should shows what are the dates for the check-in. Okay, these are the expected output. It shows the check-in date, and when we select the checkout dates here, and then it will checks out the checkout date. And then if the users click the check availability buttons, and the systems will actually display what are the rooms and the price available. So this is for positive test case. So we can put the actual results, what is actually happening. For example, if let's say the user input this value, let's say the systems will shows the calendars, and the users can select this value. Okay, similar with this one as well. This is the positive test case. Okay, so if let's say that for the negative test case, the check-in date, let's say the value is 0, 5. So this is a negative values, meaning that it's actually out of the range of a calendars. So we can put what are the actual results that we have in here, and then the check-in dates. For example, for if let's say the value here is let's say you put 15, but here you put 14, which is the dates before you do the check-in, so it will display some errors as well. So this is an example of negative case, right? Okay, so this one is just the last one, which is on the Unimas Find Food mobile apps. You can just look at our previous tutorials, and you can think of what are some of the test cases that you can actually do, yeah, or develops based on a positive and negative test case. Yeah, for examples, for the Unimas Food Finder mobile apps, you can actually search for food. Okay. Let's say this is our test case. Okay, so search for food. Maybe you can search by let's say categories, for examples. Okay, where the user just need to select these categories. There might be a drop downs. So for the user, if let's say you do a search, just a text button in here where the user need to key in the type of the food. We can do that as well, and then we try to develop what we call a test case. For example, the input just now. Okay, this is the actual result, and then this would be the output lah, the expected output. Okay, so those are the some of the test cases that you can actually develop based on these examples of Unimas Find Food mobile apps. Right. Okay, so I think that's it for our class for today. We'll just share the attendance for you to scan by each of the course code. So we start with TME.
Sir,
Yes.
I have questions regarding the project, which has to do with errors and also conceptual differences, lah, sir.
Uh,
Should I ask now when everyone is present, or only later when everyone has left and only my group is around?
you can ask now, no problems as well.
All right. So, sir, the thing I wanted to ask is regarding the undefined reference to class and also function. Okay, this one appears when I do the programming, which, let's say, for example, I have two different files, the main.cpp followed by a user.cpp. Both files have their own header. So, however, if I try to link them together, they will come out like undefined reference to user.cpp for that kind of thing. I don't know how to overcome this because personally I've been stuck on that error for around 3 days but no solution.
So your question just now is regarding not testing, right?
No, sir.
So there are problems with your header files, correct?
I believe the header file thing I did in-def and everything, and if it's already redefined. However, if I run it independently, let's say I don't add it to a project, this error appears. And on the second case, I don't know how to add things to a project because I keep getting runtime error.
How many headers file you have?
Sorry, sir.
How many header you have?
Apparently, at the moment, 60% done. We have around five different header files.
Okay, what you can do, maybe after this you can maybe you can just give me the screenshot of the errors.
Mm-hmm.
Then I will try to look at the headers that we have. What are the problems with your header files? Yeah.
All right.
All right.
And sir, another thing is when I try to implement the files and also the header files into a project in our dev C++, there is something that appears which to be toString is not defined in the scope, because the fact that I already defined the library of string and string.h, iostream, everything, it still appears that it is not defined in the scope, the function toString.
ToString.
Yes.
Of ToString.
Yes, and apparently I through Stack Overflow they mentioned something bug and all of that kind of thing, lah, sir.
Uh, did you include the string functions?
Yes, sir. I want actually the term is I would like to convert an integer to, so converting integer to string, I use the toString function. Then I will add that string into my file.
See, it's very hard for me to. I need to look at your coding. Yeah, I think without looking at it, I don't have any clue about it. So maybe what you can do is later on you just contact me. Then I will try to look at what are the problems that we can or what are the solutions that you can do lah.
All right, sir. Thank you, sir.
Okay. Okay, so if you already scanned, you can just left. Just wait for the TMS. So TMS, I will just open the attendance after this. Now it's TMN. Sorry, you cannot scan. If you cannot scan, just if you cannot scan, then for TMN, you can just leave your metric number at the chat sections. Okay, TMS, you can scan now. Will it be at night, just like previously?
Oh, okay. So because our operating system, we have our final examinations on that day as well, and it will begin 8 p.m. until 9:30 p.m.
Oh, is it at PM?
Yes,
Quite,
sir.